Hello! Today we're going to be doing a lesson on interval and set notation. So, before we continue on with what they are, we'll just need to review a couple of things first, which hopefully you've seen in the previous year. So hopefully you've seen these symbols before. Okay, so just as a refresher, the first one means that x is greater than, so let's write that down, greater than or equal to whatever number is on this other side. Okay, so let's look at the next one. X is greater than, but it doesn't have that little notch on the bottom. So this is defined as x is greater than, but not equal to, okay, whatever is on the other side, the right hand side of that caret mark thing. Now the next one is x is less than, okay, it's x is less than or equal to, and the last one is x is less than but not equal to. Alright, so we're just going to quickly put this onto another thing. Let's just add another bit of definition first before we go into interval and set notation. So I'm just going to quickly draw a number line. Okay, so hopefully you remember what a number line is. Let's start from 0. So if I want to represent a number that is on the positive side, okay, a number that is so big that the number, when we travel across here, it passes 10, 100,000, 1 million, billions. Okay, the number approaches a number that is so big, we define that number as infinity. Okay, and it's denoted by that symbol. Okay, now likewise, if we want to find a number that is so small that the number passes numbers such as -10, -100, -1,000, -1 billion, okay, it eventually approaches a number which is defined as negative infinity. The reason why we say it's negative infinity is because it is so small on the negative side that it's such a small number that it reaches negative infinity. Alright, so now that we've got this definition of what negative infinity and what infinity is, let's go into interval and set notation. So now we have 4 different questions here, in which you can see the first question asks us to represent x is greater than -3. The next one, x is less than or equal to 10, -3. X is greater than -3, but less than 6. And this last one here, we'll worry about that one when that one comes. Alright, so firstly, I'm just going to change color here. So I'm going to change it to green. So let's draw, how would we draw this on the graph? So I'm just going to draw a number line. Okay, and I'm going to start off with -3 right here. Now, let's read it out again. X is greater than -3. Okay, so if you remember the symbol, greater than. Alright, so the way we represent that is with an open circle to note down that something is not included. So, open circle, and we are concerned with all the values greater than -3. So that goes all the way to infinity. Make sure you include that arrow to denote that it's going all the way up. Okay. The next one, x is less than or equal to 10. So let's draw a number line once again. Okay, let's start off with 10 right here. Okay, so we want all the numbers that are less than 10. So going down that way. So since we have this less than or equal to, we need to make sure that we use the correct dot. You can see with this one right here that we used an open dot for something that is that doesn't include the same value. So we're going to use a closed dot for this one to say that it might include the 10 as well. So we're going to draw it all the way down because we want all numbers less than 10, and that'll go all the way down to infinity. Next one, actually before we do that, we'll tackle the interval notations. So what is this interval notation going to be? Whenever we have a open circle, open dot, or something that can't be equal to, okay, we're going to use a curved brackets. Okay, so it's going to be curved. Oh, sorry, I'm just going to quickly rub that out because it's a bit messy. Curved brackets, okay, and where does it start? -3, okay, and what section are we going up to? We're going all the way up to infinity. Okay, there's no restrictions on that, so it's going to be from -3 to infinity. Alright, now if you look at the next one, we have a closed dot on 10. Okay, and that's the highest value. So in this case, closed dots or inclusive values are represented with square brackets. Okay, that's going to be from 10. And what's the lowest value in this case? We want to go all the way down to negative infinity. Okay. A good thing to note as well is that whenever we have infinity, okay, so infinity right here, we never ever use the square brackets. We always use round brackets for infinity. The reason for that is, in theory, we never actually can determine the value of infinity. So it's always considered something that we continually approach, because infinity is not an actual stand value, but something rather we approach. Anyway, so let's go on to this next example before we tackle set notation. So I'm just going to change color once again. Okay, let's do this one. So this one, it says x is in between -3 and 6. So let's draw a number line once again. I'm going to draw -3 here and 6 here. So this symbol says that it is greater than, or it can equal to. So if you refer back to the second example, we have to use a closed dot here. Closed dot. And this symbol here, okay, will be represented by an open dot. Okay. Now, in this case, you can see there's a difference between the last two examples and this example here. The last two examples, we've had restrictions. Oh, sorry, the last two examples, we've had no restrictions. We've just said that x is less than 10. So, which is why we put an arrow. In this case, there is both a lower bound, which is -3, and an upper bound, which is 6, which is why we don't use arrows in this case. So the way we represent this in interval notation is with square brackets. We say that's -3, and it goes all the way up to 6. But does it include 6? No, it doesn't include 6, so we use round brackets. Okay, and the last one, let's quickly draw out the number line for this one. Oh, sorry, that might be confusing. I'll take that off. So, it's not drawing. Alright, there we go. So I'm just going to draw -1 here, and I'm going to draw 2 here. Now this one's tricky, so you've got to be careful. It says that x is greater than 2. Okay, so let's draw that bit first. So you can see here it says x is greater than 2, not including 2. So it's going to be an open dot. It's going to go that way. And this last bit, x is less than -1, and it includes -1. So we're going to draw a closed dot here and go all the way down. Okay, you can see there's almost this part of discontinuity here. So that's something we have to consider as well when we're going to do when we're going to use interval notation. So I'm just going to quickly change color because everything's cramping up. So there's two parts here. There's this part and there's this part. So let's write it in. So the first part is going to be minus infinity, and that goes all the way up to minus 1. And that includes minus 1, so we use square brackets. Now, I'm going to do the next bit now. So it goes from 2, it doesn't include 2, and it goes all the way to infinity. So we're going to choose that and round brackets for infinity. Now we're going to use a symbol here called the union. Okay. Now hopefully you remember from previous years that the union means when you combine this range and this range, you pretty much get what the intervals are here. Okay, so this union means combine the ranges, or combine the domains in this case. All right. So let's work what this would look like in set notation. So this might get a bit tricky, but the way we represent this is we need to write curly brackets. Okay, x, the value of x is an element of all real numbers such that x is greater than minus 3. Okay, so let's look at a few things here. So you can see that we've got this funny thing. X is an element of any real numbers. Okay, this is just a formal definition which says that the value of x can't be imaginary numbers, in which case we won't explore imaginary numbers in this video, but it's just for conventional use in this time. And this line here, we like to think of it as words such that. So if we read that out, x is an element of all real numbers such that x is greater than minus 3. Okay, so if you follow that same idea with the next bit, what we should get is curly brackets, x is an element of all real numbers such that x is less than or equal to 10. Okay, it's just a formal definition. Now, if you look at the next bit, it follows the same pattern again. Curly brackets, x is an element of all real numbers. Okay, so that means x is only in the set of real numbers such that x is in between minus 3 and 6, but not including 6. Okay, close brackets. And the last one is the same thing. Curly brackets, x is an element of all real numbers such that x is greater than 2 or x is less than or equal to minus 1. Alright, so those are the 4 different ways we can represent these inequalities. So we've got notation, which is just pretty much what you've learned in the previous years. Graphs, so don't forget that closed dot means included, open dot means not included. Okay, same here with interval notation. Round brackets means not included, but square brackets means included. And with this next bit, it's just a set definition which says that x can be, x is a part of all real numbers such that x is greater than minus 3. Right, so hopefully that was helpful.